Hello everyone. Welcome back to Random Matrix Theory. Today we'll have a short review on probability. Let's first study the case of discrete random variable. So what is a random variable? A random variable is a variable whose values depend on a random phenomena. Let's say the tossing of a coin, it's a random event, right? So the values depend on the random event. So what do we mean by discrete random variable? So a random variable x is said to be discrete if it can take only a finite or countable number of distinct values. That is, they can be defined on both countable and uncountable sample space. So today we'll give some definitions. So it's good if you become used to the definitions, and a lot of you are familiar with this because most of you have taken a course on probability at say high school level or the university level. So what is a sample space? If you don't remember, let's make it shorter. Okay. So sample space, okay, let's take it here. Sample space is set of possible outcomes of a random experiment. So if you're tossing a coin, that's a random experiment, and the sample space is just heads or tails. So there's that. So now what is probability? The probability that the random variable, let's random variable x takes so the probability that the random variable x takes the value small x, which is we denoted big px equal to small x, we defined it is defined as the sum of probability of getting that value x. So it's the sum of probabilities of getting that value x, which is small x. That is the probability of that random variable x. We sometimes denote it by small p of x, and it's also sometimes called probability function. Probability function for x. Okay. So I guess everybody's okay with this. So the next thing we should know is the probability distribution. So the probability distribution and oftentimes I'll denote it just PD of a discrete random variable X is a list of each possible values of X together with the probability that X takes in one trial of the experiment. That is, it's a list of each possible values of X and the probability of that X. Okay, and it must be in one trial of the experiment, not in the multiple trials. So that is the probability distribution. So if you see an example, that will be more clear, but let's first define the stuff and then go see an example. So also, probability distribution must satisfy the following two conditions, which is one, it must be within 0 and 1, and the sum of all probabilities should be equal to 1. This is a very popular result. This is a very famous result, so all of you must be familiar with this. So now let's go to define another thing, that is the mean of a discrete random variable is defined as mu equals x. We denote it as this. This is the mean. The next thing we should know is the variance. Mean is sort of like the average, if you all remember it from high school. It's like the arithmetic mean. It's the average of a set of numbers. So the variance is how far spread out our values are from the average value. So the variance sigma squared, it's denoted by sigma squared of a discrete random variable is defined as sigma squared x minus mu squared p of x. Also sometimes if we do some algebra, we can write it like this: x squared p of x minus mu squared. And that's variance. Also, there is another related quantity called the standard deviation. It means how close our values are to the mean, and low, if the standard deviation is low, it means our values, all the different values we have, are very close to the mean. And if the standard deviation is high, so the values are spread out, they're very far away from the mean, basically. So standard deviation SD is the square root of variance So if we know the variance, it's very easy to find out. So standard deviation is mu squared. Also the same. Yeah. It's sometimes we also write the variance as like this. Depending on the scenario, it might be useful to know this as well. And let's highlight this stuff. This is our standard deviation. Okay. So now that we have learned all the tools, let's see an example. So let's say a discrete random variable has the following probability. Oh, so since we know the shorthand notation, so the following probability distribution, let's say for these values of x, we have the probability. So if x is -1, the probability of x being in the -1 state is 0.2. In 0, it's half, and it's 1, it's a, and it's 4, it's 0.1. So then now the questions are compute, let's say 1, we have to find a, and 2, we have to find the probability such that x is greater than 1, probability greater than equal to 0, sorry, 4, the mean, the standard deviation, the variance. Okay, let's start. So how do we find a? It's very easy. Since we know that the sum of all probabilities is 1, that's a good starting point. So sum of all probabilities is 1. So we add the probabilities, and if we take it on that side, it's just this. Now, what is the probability that x is greater than 0? It's probability of 1. This is this 1, 1, and 4. So this is 0.2 plus 0.1. The probability that x is greater than 0, it's 0.3, which is 30%. Or x greater than equal to 0, that is, we have to take into account the 0 scenario as well, which is now 0.8. That is 80% chance that our value of x will be greater than 0, greater than or equal to 0. So the mean is defined as something like this. If we do it, 0.2 plus 0 times 0.5 plus 1 times 0.2 plus 4 times 0.1. So we get the mean as something like this, 0.4. The variance can be similarly found out by p of x. So in a similar fashion, we can find the variance, and it comes out to be 1.84, and also the standard deviation is square root of 1.84, which is 1.3565. So in this way, We can find the mean, the variance, the standard deviation, and we can talk about individual probabilities. We can talk about the probability distribution of a discrete random variable. For random matrix theory, it is not much important, but the most important part is the continuous case, which we will explore in the next video. Thank you.